Today we're going to talk about arithmetic sequences, which you should recognize once we get through the lesson because it is a review of something we learned in Algebra 1, but we do need it to extend into a new topic called arithmetic series later on this week. So we are going to do a little review today. So an arithmetic sequence is just a pattern created by adding the same number each time to a previous term to get to the new term. So here's an example of a sequence. 3, 6, 9, 12. So to get from 3 to 6, I'm adding 3. To get from 6 to 9, I'm adding 3. To get from 9 to 12, I'm adding 3. And so that constant that we continually add is called a common difference because we have the same number we're adding each time. So notice that it's increasing, so that common difference is a positive 3. We know that this is an arithmetic sequence because arithmetic means we're going to be adding each time. And that even goes for when it's just decreasing or when it looks like we're subtracting because we're actually adding a negative number. So if this were decreasing, then my common difference would be a negative value because I'm adding a negative number. All right, so how do we tell if it is arithmetic? Well, we're going to test by finding the difference. We need to find the difference between two terms at a time, right? So some of our notation here is when we have this a with a subscript of 2, that means I'm talking about the second term. A sub 1 would mean I'm talking about the first term. So I could take the second minus the first term, or 11 minus 2. That gives me a positive 9. I'm going to continue and make sure that that pattern is consistent with all of the terms. So I'm going to take 20, my third term, and subtract 11, the second. So 20 minus 11 is also 9. And 29 minus 20 is 9. 38 minus 29 is 9. So as long as I'm subtracting and finding the same number, right, each time that's consistent, then that means that I am dealing with an arithmetic sequence because that means it's adding by 9 each time. You could probably see that or work that in your head for some of us, but as the numbers get a lot bigger, or maybe you're dealing with decimals or fractions, knowing the pattern of just subtract the one term minus the previous term is an easy strategy. Right, so we have two different forms that we're going to learn how to write a rule for an arithmetic sequence, and the first is called the recursive form. The recursive form doesn't have a whole lot of use other than to tell you what pattern your sequence follows, right? So it's always going to give you two pieces of information. It's going to tell you your first term, which is important because you have to know where to start, and it's going to tell you what your common difference is. Now, this part that I have here in black, this is not really going to change whenever it's going to be the same no matter what the sequence is that we're dealing with. The only thing that's going to change is it's going to be telling us what our pattern is. Either we're adding a value or we're subtracting a value, which just tells us our common difference is being a positive or negative number. So some of the more confusing parts of this is really just the notation of the terminology. So you might recognize some of it, but we'll go back over what each of these means. When I have this little subscript number, that's telling me which term I'm in the sequence I'm asking about. So a sub 1 means I'm talking about the first term. If this said a sub 100, that would mean I'm talking about the 100th term in that sequence. So a sub 1 is the first term. D is our common difference. N just represents any term that we need in the sequence. For instance, if I'm talking about the 100th term, then N would be 100, right? So if I were 100th term, a sub 100, N would be 100. And then a sub N is just your result. What's the output? What is the number that sits in that 100th slot? So let's write a rule as an example. So we're going to use that same sequence here. Remember, when I write in a recursive rule, I need two pieces of information. I need to write the first term, and then I need also the common difference. Well, we know that the first term is right here. It's in front of us. It is 2. So when I write that, I'm going to write a sub 1 equals 2. I put a little semicolon between them just because I need a little bit of separation. And then I'm going to start the second part. So the second part is really easy. A sub n equals a sub n minus 1, and that does not change. sorry, my writing looks like a 9. A sub n minus 1, none of this changes. The only thing that changes is what we're adding at the end. So what is my common difference? Well, we just subtracted and we found out that our common difference was 9 in this example. So if my common difference is 9, it's a positive 9, I'm going to add 9 at the end. And that is my recursive form. We're done, right? So the only thing that changes or is different per sequence is this common difference and whatever your first term is. Everything else will be written exactly the same. Right, the second formula we're going to talk about is the explicit formula. This has a lot more use because it allows us to find any term in the sequence that we need to. So if I wanted to find the 100th term, I don't really want to go and use the recursive form, because if I asked what the 100th term was, I would need to add 9 and add 9 and add 9 and continue adding 9 to get all the way to the 100th spot. And some of you would say, well, we can shortcut that, right? If I'm adding 9, the same number each time, I can just multiply instead. You're right. And this is where we derive what we call the explicit formula. The explicit formula is our shortcut that allows multiplication to happen in order to find out that later term. So same term values, so a sub 1, d, all of those vocabulary or notations are the same, right? But this is our form. We need two pieces of information, just like the recursive. We need the first term and we need the common difference, right? So I'm going to write the explicit for the same sequence we're going to use, same example. And I'm going to start with a sub n equals a sub 1. Well, I know my first term is 2. And then I'm going to write plus n minus 1 times my common difference. And my common difference we already know is 9. So that just makes a Thanks for responding. All right, so that just makes our explicit formula 2 plus n minus 1 times 9. Right now, we need to clean that up a little bit. It's got parentheses. We can distribute that 9. So when we do that, that's going to become 2 plus 9n minus 9. And then we can add those like terms to get my explicit form as 9n minus 7. Now that just allows us to say, hey, if I want the 100th term, I'm going to substitute a 100 in for n and multiply and all of that. Well, this is asking us to find the 15th term, right? So if I want the 15th term, I'm going to substitute in a 15 for n. So that's going to look like this. So a sub 15 equals 9 times 15 minus 7. And that comes out to be 128. So what this means is that if I were to extend this sequence out to the 15th place, 128 would be there. That would be the term that sits in the 15th spot. All right, so now we're going to talk about finding the recursive rule and the explicit rules if I'm only given the other rule. So if I'm not given the list of numbers, but I am given some information about the sequence, for instance, this one, I have the recursive information. So that I'm going to try to use to write the explicit form. Well, in both of these, I only really need to know what is the a sub 1 and what is the common difference, right? So we got to know where to find that. Well, a sub 1 is 5. I know my common difference in recursive is this number that's being added or subtracted at the end. So that is my common difference there. So to write my explicit form, my explicit looks like this. A sub n equals a sub 1 plus n minus 1 multiplied by d. All right, so I just need to substitute those values in there. Well, I know that my a sub 1 is 5 plus n minus 1, and then I'm going to multiply it times d, which is a negative number, so I'm using parentheses, because if I just put -2, parentheses, thank you, if I put a -2 behind that, it looks like it's being subtracted, so make sure you use parentheses around that. So I'm going to distribute that and kind of clean it up, and that's going to give me 5 minus 2n plus 2 plus 2, thank you, and then add my like terms to simplify away. So -2n, try that again, -2n plus 7 is my explicit form. So as long as I have my first term and my common difference, I can create the other form. All right, last example. Now what if I'm given the explicit form, but I need to write the recursive? Remember, recursive, I'm just defining two things. Where do I start and what's my common difference or my pattern? So I know when this is, let's look at the first example here. This is written out in that a sub 1 plus n minus 1 times d form. So it's really obvious that that right there is my a sub 1 if we know our explicit form. And then it's really obvious that that is my common difference. So now all I need to do is put it together in recursive form. So I write my first term, which is 14, put a little semicolon between it just to give me some space. And then we write all the weird notation. So a sub 1 equals a sub n minus 1. This is the thing that doesn't change. And all I need to add behind here is whether I'm adding or subtracting a number, if this is arithmetic. So this is a positive 6, which means I'm going to be adding 6. And that's our recursive form. That's it. Okay. Now, what if it's not in the nice split up form with the parentheses where we can tell where a sub 1 and d are? What if it is just in our simplified or distributed form, like this second example here? All right, well, if it is, we still know or can see our common difference. Because remember, if this right here, let me change colors. All right, this 6, when I distribute it, it's going to multiply by the n. And there's nothing that changes that, right? So it doesn't get multiplied or added by anything else after that point. So we're always going to be able to see our common difference because it's going to be our slope. It's going to be the number that is being multiplied by our variable n. So right there is my common difference. That's obvious. Now, this number has been added and combined. It is not a sub 1. Okay, so we cannot just put that in our recursive form. It's not a sub 1. We have to figure out what a sub 1 is. Well, we have the explicit form, which allows us to find any term in the sequence we want. So to find a sub 1, I'm going to substitute in 1 for n. Right, so a sub 1 equals, and then I'm going to take negative 3 times 1 plus 11. And that's going to tell me that my first term, a sub 1, is 8. Right, so now I know my common difference is negative 3, and I know my first term is 8, so I can write my recursive form. So a sub 1 is 8. That's my first piece of information. 8. I'm going to try that again. Equals 8. Doesn't like my 8. And draw myself a semicolon to write a sub n equals a sub n minus 1. And because our common difference is a negative 3, I'm going to be subtracting 3. Subtracting negative. There we go. I'm going to be subtracting 3. All right, guys. Let me know if you have any questions online and complete your assignment. Turn it in. Thanks.